All right, this is Quadratics 15, X and Y intercepts. Here's two quadratics on the board, and we want to talk about their X and Y intercepts. Let's go to desmos.com, D-E-S-M-O-S. Graph these, type this one, and f of x equals, type it just like you see it. F of x, you could also type y equals, by the way, but this is the function notation. All right, just two of them. And we'll start with the first. Okay, did you graph it? Do you have what's the shape on your screen? What's the shape on your screen? This is big. Click this home button somewhere over here. Is there a home button? Okay, that works. What am I looking for? I want to know x-intercepts first. So on the parabola on your screen, can you click on it and find out the x-intercepts? Are you doing it, Lizette? Open a tab. Go to desmos.com. Are you doing it? Are you going? Are you going this? Are you going? Are you going? Are you going? X-intercepts. Yours looks different. Do you have the right signs on them? Something looks different. Andrea, are you clicking on them? What are the two?
-9.
-9?
That's where it crosses.
Okay. Here, hold on. And +6? Oh, +3? Yeah. So, hold on, I'm trying to think about graphing it. Here, and here. It's here, -9 and 3. And there's 2 points here. Do you remember all the names of the points? What are some of the names of the points? Several names. Do you remember them? What are they?
Vertex.
Not yet. The vertex is going to be somewhere down here because this thing goes like this. And then also, where does your parabola cross the y-axis? This is x, right? This is y. Something goes like this, right? What are these points called?
Graph.
Look at the title of the lesson. They're on the x-axis, right?
Oh, the y.
And it's where this thing's crossing the x-axis, and in math, those are called the x-intercepts. Now, where it's crossing the y, Viri, what do you call that? The y-intercept, right? These names actually not too bad. I always complain about a lot of the names in math. These not too bad. You've got x-intercepts and y-intercepts. In this case, x-intercepts are plural because there's 2, and it could only be 1 or it could be none with a parabola, right? Parabolas can go like this. You got 3 options. You've got 2 x-intercepts. You've got 1 x-intercept. You've got no real x-intercepts, right? They're non-real. They exist, they're just non-real, called imaginary numbers at that point. You'll study in Algebra 2. So here's what we're getting at in our short time. Talk to me about, we did some factoring already, so maybe your brain's warmed up on factoring. I want you to factor this now. Factor it into these 2 sets of binomials, right? What are the factorings?
9 and 3.
Good, be more specific.
Oh.
I need to know signs. 9 and 3 is right because 27, and then there's a 6 here, right? But the only way to get a 6 would be 9 minus 3. Right? Okay, so what are my 2 binomials?
-9 and -3. Wait. I'm positive.
Because x times x is x squared, -9 times +3 is -27. That's good, that works out, right? And a -9x plus a 3x would produce a -6x.
Right. Oh, no. The 3 is going to be negative and the 9 is going to be positive. It's going to stay the same.
Now it's a +9x minus a 3x, and it's a +6x. Fair enough? You're doing, remember, iterations. Iterations means I did it once, I did it twice, I did it again. I'm just going to keep going through it. Remember, take your first shot, right? Take that shot. Don't wait. If a lot of times why our dinosaur brain does 3 F's. What's our dinosaur brain do?
Freeze.
Yep. What's another F?
Light.
Yep.
Fight.
And fight.
Oh, fight.
Right? That's how we operate when we panic. And we panic a lot. Humans panic a lot. We panic almost, if a teacher calls on you and you don't know the answer, we're in panic mode. Our brains go to this right here. We freeze, right? We don't do anything. Okay, for some of us. Some of us get mad, right? I have students that are like, oh, okay, that's fine. I get it. I understand what's happening, right? Or we run away. This is how we've survived as beings for however long, since the dinosaur years, okay? Right? It's totally normal. So we have to get out of that, what's it called? To the amygdala or something. And we have to get back into the, oh, I forget right now. I'm getting off too many topics, okay? Get out of our dinosaur brain and back into our rational brain. And now you can think clearly to go through the loops, all right? Andrea, why is this x plus 9? This is right. This is your factoring. This is right. Why is this plus 9 and your root at minus 9? Yeah?
Turns into the opposite.
Pretty good. Vera, you want to add? She said when you solve it, it turns into the opposite.
I don't know.
Okay?
Like, I don't know how you get from, yeah, like that's kind of
So
crazy.
here's the setup. This has to be equal to 0. And then that allows us to put each of these equal to 0. And that's what Andrea is saying when you solve it, because I take 9, move it from both sides, and I get x equals negative 9. Oh, x equals negative 9. That's one of the roots. Oh, here's the names. Zeros. Why? Because of this whole process. Roots. I don't know why. That's what we call them. And x-intercepts, at least 3 names. Probably more if we thought about it, right? These are all names for this, right? So on your Desmos, does it tell you where it's crossing the y right here? What's our y intercept? Negative 36? I don't believe it. I don't believe that's negative 36. Really?
Yeah.
Are you clicking on it? Really? I don't believe it's negative 36. No.
No?
That's the vertex. Right here is negative 36. Look at where this thing crosses the y-axis and click on that one.
Oh, then it's
Negative 27. All right. How do we know? How do we do it manually? So look, this thing can also be written, not in function form, but y equals x squared plus 6x minus 27. At this point on the y-axis, what's the value of x? Kind of a complicated question. No, 1 on the x would be here. That's 3. 1 would be here. Is this here? No. Where is it? It's here. What's the value on x right there? 0. If the value of x is 0 here, everywhere there's an x in here, I can say 0. 6 times 0 minus 27 is equal to y. X is 0 right there. So I can replace, and you can say 0 squared, that doesn't matter, it's still 0, fair enough? 0 plus 6 times 0 is 0, gone, gone. What's left? Y equals minus 27. At x equal to 0, y is equal to, I want to just make sure and move this over. This is the minus 36. This is the minus 27, right? Just to clean up my drawing a little. This is how you solve for the y-intercept. You figure out that that's where x is 0, replace all the x's with 0, and y has to equal the negative 27. Does that make sense? Okay, so X and Y intercepts. I'm rushing only because the announcements are going to come on any second. And there you go.